Welcome back, everyone. Our final example problem is very similar to what we've been doing. So if you'd like to try example 5 on your own, I say go for it. Otherwise, follow along with Miss Long. Okay, so if you guys see here, currently, before we get started actually, let's go ahead and label the parts of the picture. Okay, so the 6 is on one of the sides of the right angle, which means it's going to be one of the legs of my right triangle. So I'm going to call this one leg 1. Okay, the Z is on the other side of the right angle, which means it's the other leg. So I'm going to call it leg 2. Okay, each of these are the pieces of the hypotenuse. Since Y is closest to leg 2, I'm going to call it the piece of the hypotenuse 2. And since the 3 is closest to leg 1, I'm going to call it POH1. Okay, and the X is the entire side of my right triangle that is across from my 90-degree angle, so it's the hypotenuse. Alright, now, if you guys see here, what part did I not label in my picture that we normally label? I did not label the altitude because I don't have an X on there, or I don't have a variable on there, and I don't have a side length. Okay, so this problem, we're not even going to be dealing with the altitude. Okay, so what that means is I'm not even going to use this formula right here because we're not even given an altitude. Okay, we only have legs on here. If you guys see here, we have a leg 1 and a leg 2. Okay, so since we have a leg 1 and a leg 2, we're going to be using the second formula 2 times. Okay, now, there's a lot going on with this problem. Okay, and you're probably like, well, I guess it doesn't really matter where we start from. Well, it actually does, you guys, and the reason why is because we have a lot of variables going on. Okay, and depending on how we set this up, one way we're going to have enough information to solve for a variable, the other way we're not. Okay, so if I'm looking here, I'm just going to set them up. Okay, so on this first one, which you'll see why, but on this one we're going to solve for X first. Okay. So on this one, we're going to use our formula twice. We're going to have the hypotenuse over, this one has Y and Z in it, which Y and Z are on the POH2 and the leg 2. So I'm going to start with leg 1 and POH1. Okay? So our formula is the hypotenuse, Okay, our formula is the hypotenuse over leg 1 equals leg 1 over the piece of the hypotenuse closest to leg 1, which is POH1. Okay, and my other formula is going to be the hypotenuse over the second leg, so leg 2, equals leg 2 over the piece of the hypotenuse closest to leg 2, which is POH2. And again, you guys, don't forget, since these are geometric means, across one of the diagonals, our values should be the same. Okay, now if we're looking here, I'm just going to kind of walk you through how you'd set these up, which will tell you which one you should solve first. Okay, so hypotenuse is X, so we're going to have X over leg 1, which is 6, equals 6 over POH1, which is 3. So X over 6 equals 6 over 3. So this problem only has one variable, which means I can solve. Currently, if I try to set up this one, I'm going to have the hypotenuse, which is X, over leg 2, which is Z, equals Z over piece of hypotenuse 2, which is Y. So I have X over Y equals Y over Z. Well, currently in this one, I don't have any of my variables, which means I cannot even start solving that one yet. Okay, so I'm going to have to use this one first, and after we solve for the hypotenuse first, which is X, that will help me to find Y and Z. Okay, so I'm going to set up this one first, okay, which I already kind of told you how to set it up. The hypotenuse we currently don't know, which is X, over leg 1, which is 6, equals leg 1 again, so 6, over the piece of the hypotenuse that's closest to leg 1, which is POH1, which is 3. Alright, let's start cross multiplying. Let's go. Okay, so X times 3 will give me 3X. And that will equal the other way. So 6 times 6 is 36. Okay, let's solve for x, which will be our hypotenuse. Okay, so remember the 3 and the x are secretly multiplying to each other. So the way that I bring 3 to the other side is by dividing both sides by 3. And 3 divided by 3 will cancel and turn to 1. And 36 divided by 3, well, 3 divided by 3 is 1. 6 divided by 3 is 2. So 36 divided by 3 is 12. Okay, so my hypotenuse length is 12. So I know the whole thing is 12. Okay, so if I know the whole hypotenuse is 12, and I know one piece of the hypotenuse, how can I find y, which is our missing part of the hypotenuse? Okay, I know that the whole thing's 12, and part of it's 3, so what's left over to give me the remaining part of the hypotenuse? Okay, well, what I'm going to do to find y real quickly, okay, y is going to be the hypotenuse minus the piece that I already know, which is 3. That will tell me what's left over. So 12 minus 3 is 9. Okay, so I already know that y is 9. Okay, so the piece of the hypotenuse 2 I now know is 9. Okay, so now that I know my hypotenuse and my piece of the hypotenuse, now I can actually solve for the leg, because now I'll be down to just one variable. So that's why I started with this formula over this one. Okay, so let's set up our final formula, and then we can just solve and be done, which is kind of sad. I hate when the problem's over. Like, that's like the worst feeling ever when a math problem finishes. I mean, but it'll be okay. There's always going to be another math problem, right? Okay, so my hypotenuse, we now know is 12. So 12 over leg 2, I still don't know, which is z. Okay, will equal leg 2 again, which is z, over the piece of the hypotenuse that's closest to z, which is 9. We know it's 9 now. It's y, which is 9. And from here, we just solve. So let's go, let's go. Okay, so z times z, oh, good golly, Miss Long. Z times z is z squared. And that will equal 12 times 9, which I think is 108. But again, it doesn't hurt to double check. I'll just do it over here just to check. Doesn't hurt to check yourself. 9 times 2 is 18. Carry the 1, 108. There you go. Okay, and let's finish. So how do we undo a square? We do square root that thing. I'm going to square root it on both sides, which the square root will cancel out the squared. Okay, so I'm left with z equals what appears when we square root both sides of an equation? A plus or minus. And is 108 a perfect square? No, it is not. So what do we do when we don't have a perfect square and we're trying to square root it? We do our factor tree. So we're going to break it on down. And don't forget, you guys, z is a leg of my right triangle. So we remember that in our final answer, we don't include the negative, because the negative leg doesn't make sense. Okay? All right, so I'm going to break it on down over here. I'm going to squeeze in my factor tree over here. So let's do it. Break it on down. Sorry, that's a 108. 108. Okay. So, two numbers that go into 108. Well, I know 12 and 9 do, because I did 12 times 9 to get 108. So I'm going to use those two. Okay, 12 breaks down into 3 and 4. 4 breaks down into 2 and 2. 9 breaks down into 3 and 3. Let's see what happens. Okay, do you guys spot any cute little couples that get to go on their math date? Do you guys see any? I see a pair of 2s. And I see a pair of 3s. And don't forget, for each pair, only one number will hop outside the radical. And if we have more than one number, we multiply. So I'm going to multiply the 2 to the 3. So 2 times 3. And then do you guys see any lonely single numbers that don't get to go on their math dates? They have to stay in for the night. That would be my lonely 3. My lonely 3 stays in for the night. Okay, so my final answer, which will be the end of this problem, so I don't want to end it because then it'll be sad, but it'll be 2 times 3, which is 6, root 3. And that is it, you guys. That's all I've got for you. Nice work, you guys. Nice work.